Okay. So hi everyone. Some of you in the room might know me, but the vast majority of you definitely won't. So I've flown in from Australia to be at this event, but also to visit a couple of companies that are working in the flat panel antennas market, which is a study at the moment that I've been working on for the last couple of years. And to disarm the room completely, please consider me a mere mortal in a room full of very experienced people that have got a lot of knowledge on this subject already. My journey has been to try and translate what you guys all know and get it into some level of English that can be written down and understood by the masses that are very interested in this subject today across a vast number of verticals. So I'm co-founder at Valour Consultancy, an independent intelligence firm that's based in the UK, but has a small office in Australia, which is where I'm based now. As I mentioned, the whole purpose of this seminar, I've had the privilege to be invited to speak today, and I thank Ayecka for inviting me to talk to you about the journey that we've been on writing this report. Everybody has their own definition of a flat panel antenna, which is something that I learn very quickly. To give you the scope of the report and the intelligence I'm about to talk through, we focus on comms on the move. So our whole remit as a company is to provide intelligence services to aviation and maritime in particular. So customers range from satellite operators, service providers, end users in those segments. And we've actually, through this report, now moved into the land mobility space. So this was a completely new jump for us as a company, and it's been one that's been incredible to be on. We're focusing, our definition of flat panel antenna is a solution that's less than 7 inches in height. It focuses on comms on the move, obviously, and we've not captured the IoT space in this particular study. We've been looking at those solutions designed for broadband access. So that should give you a range of the type of terminals that we're looking at. And then in terms of the verticals that we looked at, the applications, they range across aviation, maritime and land. And the topics of discussion that I wanted to bring you in terms of the insight that we've gathered really relate to the subject of today, which is the reliance and the importance of LEO and MEO constellations in the evolution of this technology. So we look at it from a driver and how NGSO constellations are fundamental to the evolution of this flat panel technology. I'll have a look at the competitive environment and talk you through some of the key vendors, and then we'll look at the role that low Earth orbit and MEO operators have got in those vendors that go on to succeed in this space. And then finally, just looking at the market sizing in our view. So I've got some numbers that talk about the addressable market that some of these players are playing for, and we'll talk about the impact that LEO and MEO has had on that market size. So first of all, let's dive into the first, which is the importance of LEO and MEO on this technology. So appreciate that the text of this slide is awful for those of you in the back of the room, but in a nutshell, I've segmented this importance into fundamentally, we've seen that LEO and MEO constellations have opened up new applications in comms on the move. Some of the verticals that we'll look at later, we're talking about brand new applications that are looking for better coverage, increased redundancy, latency, and pricing as well. So that's one of the first things. In terms of the actual antenna technology itself, some of the fundamental factors around LEO and MEO, most specifically the need to track, the need to switch beams more than ever before, the need to look at multiple satellites that operate on the horizon and choose which of those satellites to talk to, is driving this need for this new technology, this new generation of antennas that are coming through in development now. It's not a new technology overall, I appreciate that, but we're seeing these flat panel antennas come through into the market that are optimized more than ever to work with these MEO and LEO constellations. And the technology that we see already coming into the market is literally the first wave of solutions. And what we anticipate seeing is that these solutions continue to improve in terms of designing capabilities, and the collaboration that we see going on in the market is going to shift entirely. So who are the key players? In terms of this chart, just to kind of talk you through, I've got down here the 4 types of antennas, and again, everybody has their own way of segmenting the market. But for us, we've included in the scope of this report, purely because of its presence in the aviation space, and leverages mechanical steering, so it's not a gimbaled antenna as such, but it is, and I will acknowledge, it's a mechanically steered antenna in the way that it beam forms. So we've included that one, and along the bottom here, I've created a scale where we're looking at those companies that are still in design and development versus those companies that are in early stage production and then moving into full scale production. And as you can see on the right hand side there, ThinCom are firmly in that category. The busiest channel, if you like, is within this phased array section. And in here we've got a big group of companies that are in that design and development stage, pushing towards early stage production. Within that, we've got GetSat, Intellian, Hughes, which is a fairly recent announcement on the Intellian side. And already in full-scale production, we've got the Ball Aerospace antenna, which works down from the military vertical and has been integrated into commercial and business aviation through a relationship with a company called Stellar Blue. And as we'll see on the next slide, that antenna has already been adopted by a LEO operator. We've got Starlink over here that's, again, full-scale production of its enterprise terminal for the maritime space and in the fixed broadband market as well. In metamaterials and lens antenna, so lens, known as optical, I guess, antenna, got a really interesting concept from Allspace that for now is still in that early stage production. It's been very active in the military vertical, and as again we'll see on the next slide, has already got a relationship and collaboration with SES as part of its MEO constellation. So that's a really interesting terminal, and it's multi-beam, multi-orbit capable based upon the tests that have been carried out so far. And it'll be really interesting for me to see how that terminal goes. And then obviously Kymeta, which again, designed for much smaller applications, tactical vehicles and vessels. And after a slow start, it was one of the early contributors to this space. It's now starting to ship hundreds of terminals every year, and its price point is below the $20,000 mark. Low power solution, but nevertheless one that is currently shipping. Now, when we come to the important part around the influence of LEO and MEO in terms of the decision process and those that go on to succeed, what we've seen so far is that we've got KU band LEO operators and MEO operators. We've got obviously SES as well, but these two in particular have been very notable in terms of driving interest and intrigue in this market. And we've got OneWeb in particular that and a lot of relationships and a lot of collaboration with companies in this space. So the Hughes one is, again, fairly recent. Hughes is heavily involved in the ground network of OneWeb, the modem supplier, and it's been a natural fit that its antenna is now been adopted across the business aviation market in that space, and then the maritime and the land mobility space. But it's also forged relationships with Ball Aerospace, Panasonic and Intelsat are two very influential companies in the market. Satcom Direct, they've all adopted this Ball Aerospace ESA as part of their next generation offerings. So a lot of the decisions that have been made by these companies are determining those companies that go on from an antenna point of view to succeed at least at this stage. So collaboration is a crucial ingredient here, and certainly not the only one, but one at least in this first wave that's determining those that go on to at least generate some success. So the next section and the final section looks at where the opportunity lies. We're about to see some numbers that don't represent what we view as actual shipments of ESAs and flat panel antennas into this market. What I'm showing you here are numbers of vehicles and assets applications that we think ESAs can penetrate in the next 5 to 10 years across these different verticals. What I've got down here as well, which you'll see appearing on most of these slides, is I've looked at, again, criteria for success, which we analyse in the report. We've got the presence of alternative technology, so IoT, cellular-based connectivity, and price sensitivity. So, how sensitive is each vertical? And I've tried to rank each of the following segments into that. Is it a ripe market for ESAs, or is it one that we don't anticipate ESAs to penetrate? And in the military case, what we see is a desire for discrete technology, at least in the mobility space, and one that's got robust connectivity, offers that redundancy in all areas of operation, not just in the US, for example, but anywhere these vehicles and assets are deployed. That quality of service is key. And we've also seen a transition, or at least an intent, to move more and lean more on commercial networks as opposed to the proprietary military networks that are certainly not going anywhere. And I should also preface this by saying we don't anticipate that ESAs are the silver bullet. We do think that parabolic and existing solutions will remain present. But certainly that transition and more openness towards commercial networks and that need for multi-orbit capacity is one which we think government and defence represents the low-hanging fruit for this technology. In the commercial and business aviation space, which are the two numbers that we've got over here, we've got about 12,000 aircraft on the commercial side that will have in-flight connectivity. And within those, there's a lot of aircraft that already have the ThinCom VIX antenna. And there's a lot of aircraft that will soon have that ESA from Ball Aerospace. It's potentially part of the line fit market for Airbus. In both of those markets, and I would argue in government defence, what we're seeing is a transition away from GEO-only services into one where airlines can guarantee more quality of service and shore up the service level agreements that they want to be able to offer their passengers. And so we're seeing that transition to multi-orbit where LEO and MEO are being layered in to those geostationary orbits. And both Intelsat and Panasonic have so far announced their intention to do so. So new customers will be transitioned onto the ESA from Ball Aerospace, and we anticipate more vendors will do that as well. So this is the exception, and that's at the moment a LEO-only service. And so far we've seen a couple of airlines, 3 to be exact, already opt for that service, and so we anticipate that will also be a big feature of the commercial and business aviation market. So for us, this market is also one of those that's green. We think it's a market ripe for ESA technology. There's a big number of vessels that are connected with maritime connectivity. The majority of that is in L-band today, L-band SATCOM. Where the volume currently lies is in merchant and fishing, very price-sensitive markets where we don't anticipate ESAs will necessarily penetrate too significantly. But what we do see is that already SpaceX has already moved into the passenger market. It's installed 7 or 8 terminals on a single cruise vessel, and those cruise owners are actually rolling Starlink out across the fleet in a couple of cases. And in the high-end leisure market, I've been to Holland recently, the Netherlands, and seen like 2 or 3 boats in the marina there that have Starlink already. And our understanding is that many shipbuilders are now looking at installing Starlink onto the high-end leisure market. So we don't see maritime as like a high-volume opportunity, but certainly one that will benefit from like low cost that LEO can bring to that section. First responders is a market which at the moment we don't consider necessarily ripe for ESAs, purely because there's high alternative technology with cellular and dedicated networks that serve those assets. But what we do see is that in terms of command and control in the fire and police sector, we do see that there's a small opportunity, a niche opportunity in those sectors. And also in telemedicine, particularly markets where there's low cellular coverage, Again, very high price sensitivity for that application, but one where we do see there's a potential opportunity in some of those markets for the right priced ESA antenna. And at the moment, the way that Starlink's going, that LEO only service could be one of those solutions. This one's like a really interesting one from me. So I interviewed Komatsu, who provides a lot of the surface mining vehicles. And a big trend there is moving to autonomous vehicles, autonomous mining. And particularly where I'm at in Australia, I've interviewed a few of the mines there that are looking to move, I guess, control, if you like, of those vehicles into urban hubs as opposed to having them allocated at the mine. Today, they are being very adequately served by a fixed solution that's installed at the mine. But on these vehicles, you know, the tyres alone are more expensive than what a single SATCOM solution would be. So price sensitivity isn't an issue. It's overcoming the alternative technology in that market. But with the way that that's moving to autonomous mining and the need for low latency video, this feels like one of those addressable markets that does have some potential for SATCOM and also potentially for flat panel antennas, with LEO being a key for that market. And then finally, the connected car, which has extensive volume opportunity over the next 5 to 10 years. Volume is not an issue in this market. As far as I can tell from the work that I've done, the problem is actually, first of all, the cost of a solution versus the cost of a vehicle. It represents such a significant chunk of the tens of thousands of US dollars that a car sells for, and that's a problem at the moment. Also the presence of IoT and cellular, which I think is more ripe for this kind of market as opposed to the need to provide broadband access. So for me, this is one of those markets where if ESAs do penetrate, it'll be more on the IoT side as opposed to broadband access. So I've given this a red in terms of the scope that I'm looking at, but one that is an opportunity. So in terms of key takeaways, I rushed through those slides, so I do apologise, but I had a stiff 15 minutes. For me, if I look at the role that LEO and MEO has to play in the flat panel market, we're seeing it drive an evolution in incumbent technology and driving out the need for these flat panels. It's also opening, we're seeing that operators, LEO and MEO, are determining those companies that go on to be successful. That collaboration, the knowledge of the constellation from the ground up is crucial, and we're seeing that play out. And then third and finally, we feel that we're seeing LEO and MEO, particularly LEO, drive huge opportunity in markets where SATCOM necessarily hasn't been present before. And even in those markets where SATCOM has been present, it's helping drive the business case, because for the first time, we're actually starting to see cost-effective capacity and solutions come to those markets to challenge incumbent technology. So for me, it's a fundamental link. And with that, that's everything.